Okay, this is my videotape discussion on heating curves. So this is the graph that we were supposed to draw on page 523 of the chemistry textbook. So it is a basic heating curve of water. So this is the solid form of water, liquid form, and the vapor form. And the x-axis is heat, so as heat is supplied. And the y-axis is temperature over here. So, the first question, identify which regions of the graph is temperature constant. So, the temperature, which is the y-axis, is constant in two locations. So, that is where the temperature is level, or the y-axis is level. So, that would be here, the heat of fusion, and then over here, which is the heat of evaporation. That is where those take place, and that is where temperature is constant. Now, question number 2. How does the amount of energy required to melt a given mass of ice compare to the energy required to vaporize the same mass of water? So as you can see here, there is a smaller amount of time and heat. Sorry, this isn't the time. The small amount of heat needed to go from solid to liquid than it is liquid to vapor. As you see, this is a very long segment while this is really short. Now this is mainly because when a solid turns into a liquid, the atoms inside of a solid are already vibrating, and when you put heat through it, it can actually melt from the inside out if it needed to, but usually it goes from the outside in. But heat is constantly being pushed through it, so it can easily go from a solid to a liquid. But when you're going from a liquid to a vapor, on the other hand, only the surface of the liquid gets evaporated and vaporized first. So it has to go from the top layer, and once that evaporates, the next layer, the next layer, the next layer, the next layer. So it takes a lot longer for that to happen because of the amount of surface area that the heat can get to, while in the solid, the heat can go right into the middle of it and heat it up. While in the liquid, it has to go through the top first and then keep going. And there was, what was the other? Yeah, the other reason is because when you're going from a solid to a liquid, it's easier to break apart the atoms, and so that they can roam a little more freely. But when you're going from something that's already pretty much free-flowing to something that's even more free-flowing, more expanded, as you're trying to pull the atoms farther and farther and farther apart, it gets more difficult, and more heat and energy is needed to pull them apart. So that is why going from solid to liquid takes less energy than going from liquid to vapor, because of how easily the atoms can be taken apart. Okay, so 3a, which region of the graph represents the coexistence of solid and liquid? So that would be here. This line right there is the coexistence point of solid and liquid, which is the melting point slash freezing point, depending on which way you're going. So if you're going this way, it's freezing, this way solid. So that's why they coexist, because they could either be going it could either be melting, or it could be solidifying and freezing. So that's why that is the coexistence point of solid and liquid. And 3b, what region of the graph represents the coexistence point of liquid and gas? So that would be this line here, where the liquid is either vaporizing or the vapor is condensing. So as I said, with the solid and liquid, because it's both either vaporizing or condensing, it is the coexistence point between the two. So that was my videotape discussion on heating curves, or the videotape discussion of heating curves based on the energy that it takes to go through the different phases of water. So, hope you enjoy.